Algebra 2, we are going to start section 2 talking about direct variation and what it means to be directly related or directly proportional. And it just stems from this equation. If you look at y equals kx, we call k the constant of variation, and you might be looking at that and saying, well, it looks a little bit similar to y equals mx plus b, and you'd be right, except that there's no b value. Or in other words, the b value is 0. So if I ever ask you to graph y equals kx, what it'll look like would be a problem, whatever the k is, kind of looks like the slope, where it passes through the origin. And what you can do is you can actually set up the problem that way, where you can, you have to read the directions that it says that it's directly related. And what that means is you can find the k value. In this situation, we know that y is 15 when x is 5. And so you can find the constant of variation by dividing 5 over, and 15 divided by 5 is 3. And so what that means is that you can use that equation and replace k with 3. And now you can figure out what y is when x is 9. And 3 times 9 is 27. And I realize that there's faster ways of doing this, but right now I want you to have a this equation that you can fall back on. So I'm going to explain the next one the same way. That we have y equals kx. So when y is -6, the x value is 4. And so you can find the k value by dividing that 4 over in order to cancel it out. And if you reduce, then you have k equals -3/2 because they're both divisible by 2. So I can go back to that equation and rewrite y equals and replace the k with -3/2. And now I can plug in -10 for x. And maybe you need the help of a calculator, but a negative times a negative is positive. And you just multiply the whole number into the numerator, so 10 times 3 is 30, divided by 2 would give me 15. And maybe I'll show you your shortcut on this last one, because you could use this expression, because no matter what the constant of variation is, it has to be the same number all the time. It's constant. So what you could do is set up an expression using y over x. That's why it's called proportional, is proportions are equal fractions. So if you set it up as 12 over 16 is equal to y over 24, then you can cross multiply and divide. So maybe I'll get a calculator out just to remind you that when you cross multiply, it's 24 times 12 divided by 16. The only reason why I'm nervous about teaching you this way is because I think some people will mess up setting it up. So this correct answer would be 18. So I want to let you know that that is an option for you. I just have a different way of solving it that is sort of, I like to use the phrase foolproof. And the reason why we do that as well is then we can set up problems that follow from direct variation. So that's what this word problem is, that they tell you this individual, Phoenix, traveled 78 miles in 1.5 hours going at a constant speed. And you may remember this from science class, it's the equation distance equals rate times time. So if I set that up, the distance Phoenix traveled was 78. And 1.5 hours stands for the time. You just don't know what the rate is, but it's set up as, if you notice the comparison, this looks like y equals kx. It's just d and t with the constant of variation r instead of k, y, and x. So anyway, if I did the problem using distance equals rate times time, then it would be 78 equals rate times 1.5. So to solve for the rate, the average speed, you would divide that 1.5 over to cancel it out. I need a calculator for that. I don't expect you to know 78 divided by 1.5 in your head. So it's 52. And so from here, how far will Phoenix travel in 2 hours at the same speed? Well, this time the question is how far, so we're asking D. We now know the constant of variation is 52. After 2 hours, so T is equal to 2. And I think you could do that in your head. 50 times 2 would be 100. 2 times 2 would be 4, so 104 miles. There you go. So a little application to direct variation. Another situation, and notice in the directions, even if you don't know they vary directly, they tell you in the problem. And what's super important about that is it says the pay, so maybe you use P for pay, and you don't know what that variable is, so maybe you call it K again for the constant of variation, to the number of hours she works. So maybe you put in H for hours worked. So in the first situation, you could look at that and say her pay was $274.75. You don't know the constant of variation. You don't know how much she gets paid per hour. But if she works for 35 hours, you can replace the H with 35. So you can solve for her hourly wage, hourly pay, by dividing that 35 over. And again, I expect you to use a calculator. That's a tough problem to know 274.75 divided by 35 in your head, but that's 785. So K is equal to 785. So how many hours would she need to work in order to earn 337? And this is why I like using variables that are related with the problem, because this is her pay. So if you use P for pay, then it might make more sense to set up the problem this way. 785 is the constant of variation, but you don't know how many hours. That's what the question is, how many hours? So to solve that, you just have to divide the 785 over, because that's a multiplication problem. And to solve multiplication, you have to divide. So 337.55 divided by 785. And you see she has to work 43 hours. And I don't want to get into a discussion on what about overtime and things like that. Right now we are in math class. Let's sort of stick with easier concepts as far as that. I realize that there would be overtime and maybe she would only have to work 41 hours, but that would make the problem a lot more complicated. Okay, so we can also do direct variation with a graph, and I already touched base on that with how it's y equals kx kind of looks like slope-intercept form. So what that means is it has to pass through the origin. So sometimes what I'll do is, so they tell you the problem when x equals 6, y equals 4. So a good visual for you to answer some other questions would be to connect these dots and then look at other ordered pairs on this graph. Now that's not exactly the intent of this problem. The intent of the problem is to get you to understand that it's going to pass through the origin. So if we did the problem the same way I talked about earlier, that you could figure out the constant of variation. I'll do this off to the side, that y equals kx. So if y is 4, k times x is 6, you could divide that 6 over to figure out the constant of variation is 2/3 when you simplify. So if x equals 3, using that equation, 2/3 times 3, well, the 3's would cancel, or it might help you understand if you did 3 times 2 is 6, divided by 3 is 2. So the ordered pair we're talking about there would be 3, 2. And then I could do the same work using -6 for x. So y equals 2/3 times -6. And remember, you multiply the whole number into the numerator and then divide by the denominator. So it would be -12 divided by 3 would give you -4. And -6, 1, 2, 3, -4. And I started to draw the line earlier in this color, so I'll go ahead and do that this way as well. And we can answer these questions, I think, pretty well. So the constant of variation, remember we used k a lot for that, was 2/3. We solved that. And what does it represent on this line? It is the slope of the line. And if I asked you to write the equation of this line, it would be in slope-intercept form, y equals 2/3 x. You don't have to write plus 0, but that might help you understand direct variation, especially if you are good at y equals mx plus b. And that's exactly what this is saying. It exists two variables whose value are 0 at the same time. That's what simultaneously means. And we have one more word problem, just one more word problem, where they're getting you to understand the comparison between miles driven, number of gas in the car, and Abigail was able to drive 336 miles on 8 gallons of gas in her hybrid vehicle. So why are they asking you to do d divided by g here? Is because if you set up a constant of variation problem, d equals k times g, then you can solve for it by dividing the g over. But in this problem, I want you to specifically write out the units. And on 8 gallons, because as you divide the 8 over, the constant of variation actually represents a number. So let's figure out what that number is. 336 divided by 8 is 42. The reason why you need to have your proper units down here is when you divide, you might write it as miles over gallon. And the intent of this question is to realize that what you're really finding is miles per gallon. You may have seen that before. I'll actually write it out. Miles per gallon. Anytime you see a division in math, that's the word per. So just to help you familiarize yourself with some words, that's why your parents or maybe you, since you're about to drive, if not already, concerned about miles per gallon. How far can you go for each gallon that you pay? So if I ask you to create a linear equation that represents this relationship, it would be d equals 42g. Because if you have 8 gallons of gas, like in this problem, if you multiply by 42, you can get to 336 miles down the road. And that can help you answer questions like this. So how far can Abigail drive on 6 gallons of gas? Well, plug in 6 for G. And again, I'll let you use a calculator. 252. Miles. There we go. And then how many gallons of gas will Abigail need in order to drive 483 miles? Well, this is a little different because now 483 is the D value, and you need to solve for G. Well, you can solve for G by dividing that 42 over. So 483 divided by 8. Well, nope. 483 divided by 42. There we go. Took them 11.5 gallons. So that's what G would equal. And you should be ready for your homework. Section 1.